Hi everybody, this is Mrs. Dinkelman, and this is part 2 of the 6.5 notes where we're going to talk about what happens when we have an integral where we know we're going to get a log as our answer. And so there's really just these couple of rules that I want us to zero in on. So one of which is when there's an x to the 1 in the denominator, that's when we should understand that there's going to be a logarithm as our integral, and it's not a reverse power rule. And I'll kind of show you that on example 11 here in just a second. The second thing to notice is perhaps a u substitution, although I try to avoid u substitution if I can. So the way I notice what's happening is we have a function on the bottom and its derivative on the top. So what I like to say for myself is if the derivative of the bottom is in the top, and I'm going to use math language here, if the derivative of the denominator is in the numerator, it's natural log. Okay? And I'll kind of show you that, and also show you u substitution there if you'd like. So what I was saying earlier is if we accidentally think of this as negative 3x to the negative 1, when we try to add 1 to the exponent and divide by the new exponent, I hope you are like, what in the world is happening? Okay. So that's when I want you to know that this is really just a natural log. So it's maybe helpful to think of the negative 3 on the outside and the 1 over x dx here. And we put absolute values there because we don't really know, and that's kind of this discussion up here. We don't really know if there's a domain restriction or not, and we know we're not supposed to do natural log of negatives, so we tend to put that. If you don't put it, you're not going to get marked wrong, and they don't make you choose between the two of them, just by the way. Okay, number 12 is kind of like this second thing I said, where the derivative of the bottom looks to be in the top, meaning the derivative of p squared plus 1 is 2p, which is really close to what's up there. So my instinct is just to jump and say, okay, this must be natural log of p squared plus 1. Problem with that, and that is I don't know what the coefficient is. And because the derivative of the inside is a 2, and there's not a 2 up in the original, I just kind of mathematically think about there must have been a half here so that the 2 somehow goes away. So I like to jump straight to the answer. So I do the same thing for 13. Derivative of tangent is secant squared. So this is just natural log. It's always natural log of the bottom. Okay, same as over here. It's natural log of x. And again, I like to think derivative of tangent is exactly secant squared, so I don't have a coefficient that I have to worry about there. Now, let's say that's not an obvious thing to you. You still kind of have to think about this being a natural log, and so you would have to do a u substitution. How are you? Good. So if u equals p squared plus 1, du is 2p dp. And remember, we solve for dp. The nice thing about u substitution is you don't have to think about where that 1/2 that I had up there earlier, where it comes from, because it just kind of pops in there. So we're going to have p over u, and then du over 2p. For me, again, I like to think of this 2 as a 1/2 on the outside, so that I can see that it's 1/2 natural log of u, and then again plus c, all natural log or all u sub, we have to go back to that original. So you can see that's how we would get to a natural log, and it does not bother me if you do u substitution on those. It's not a huge deal, but if you can get away without doing it, that's totally okay too. So we do something similar. U is going to be the denominator because we need the other part to be the derivative, and it is. Solve, and again, you might be starting to sort of skip a few steps in here and notice what cancels, which is totally fine, as long as you're not missing things that make you get the answer wrong. I forgot that's going to be my u. I better erase that. I made that my u to make my life easier. Just talking and writing at the same time. Okay, so again, those secant squareds cancel. I have integral of 1 over u du, so natural log of u, and u was that tangent. Okay, so 14 and 15 are also going to be U subs because I just want you to see, we see this 1 over x on both of them. I know there's not a 1, to kind of circle there for number 14, but the derivative of natural log of x is 1 over x. So I see a function and its derivative in there. And the same thing for 15. If u is just that 2 minus natural log of x, then du is negative 1 over x dx. So again, just kind of noticing after you take the derivative that something is going to cancel eventually. All right, so this one ends up being, I guess I should solve for my dx over here. Dx is x du. So we're going to have u over x du. So the x's cancel. I'm running out of space, so I'm just going to say, all right, that's u to u. So u squared over 2 plus c. And that's actually natural log squared over 2 plus c. Over here, dx is negative x du, and I'm going to rewrite this integral. So it's really a negative, I guess I'll leave the negative on the outside, u to the negative 3 du. So negative, and we're going to add 1 to the exponent, divide by the new exponent. So really that's a positive 1 over 2u squared plus, oops, I was going to put the plus c in the denominator. That's not correct. Plus c. And then the u was that 2 minus natural log of x plus c. Okay. All right, so then 16, 17, we see these a lot actually in C class. We're going to write cosine or cotangent as cosine over sine. And then we're going to write tangent as sine over cosine. And we could do u sub. I'm going to kind of cheat a little bit, but if you want to try u sub and make sure you get the same thing as me, you're welcome to do that. So u is going to equal the denominator. But I'm going to say, again, the derivative of the bottom is in the top. So then I know that the answer is natural log of the bottom. A little adjustment on 17. Derivative of cosine is negative sine. So that means I kind of have a negative problem. So I better put a negative out front. Again, if you do u sub, you don't have to think about it. And then just a quick bit about that negative. It gets to pop up here like a negative 1. And then cosine to the negative 1 is actually secant. So sometimes you'll see that happen. Okay, real quick before people walk in, there's a little bit about this one. Okay, on there, I wouldn't have those memorized. I just do u sub all the time on those. So you should be able to get to the whole assignment for 6.5, and good luck.